we're going to be looking at slant asymptotes for this lesson. Their learning objectives: given a rational function in symbolic form, graph the function. Rational functions we looked at in more detail last unit. In last unit, we defined a rational function as f of x is equal to p of x divided by q of x, where both p and x and q of x are polynomials, and we had a restriction that said this is the definition of a rational function as long as your q of x is never equal to 0. Now, some of the things that we did last unit for rational functions when we graphed them is that we identified holes. And if you remember, holes exist when you have a common factor in both the numerator and the denominator. So you have a common factor that exists in p of x and q of x. We also looked at vertical asymptotes, and vertical asymptotes were the values of x where your q of x went to 0. So this would be x equal to something. Now for the holes, our holes were actually a coordinate point, so we'd actually have to find the x and the y. And then we also talked about horizontal asymptotes. So for horizontal asymptotes, we used the acronym BOSTON. And with BOSTON, we used this little mnemonic here to determine what type of horizontal asymptote exists. So what we did was we compared the degree of our p of x and the degree of our q of x. And we said if the bottom degree was bigger, we had a horizontal asymptote of y equals 0. If they had the same degree, we said that we take the ratio of the leading coefficients. So we would end up with y is equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. And then we said if the top degree was bigger, we had no horizontal asymptote. So for today's lesson, we're actually going to be hanging out right here. So we're going to look at, because sometimes our p of x degree is actually bigger than our q of x, and it's correct in the sense that we have no horizontal asymptote. But there is something else going on here, and so that's the purpose of today's lesson. By the way, if you haven't noticed already, I'm using the PowerPoint that's available on Blackboard. So let's define our slant asymptote. A slant asymptote is basically a line. So our asymptote could have a positive slope. Our asymptote could have a negative slope. A slant asymptote is going to occur when the degree of the numerator is larger than the degree of the denominator by exactly 1. So if my degree of my numerator is bigger than the denominator by 1 degree, then we're going to have an asymptote that is slant. Now, how we go about finding slant asymptotes is using long division. So let's take a look at our first example here. Determine the equation of the slant asymptote. So the first thing we want to do is we need to compare the degree of our numerator and our denominator. And we need to confirm that a slant asymptote exists, and in fact it does. So we know a slant asymptote is going to exist for this particular problem because the degree of my numerator is 3 and the degree of my denominator is 2. And since 3 is greater than 2 by 1, then we have fit the criteria. All right, so now how do we find that slant asymptote? We use long division. All right, so let's set up our long division. We have 2x squared minus x minus 1, and we're going to divide that into 6x cubed minus 5x squared plus 4x minus 1. So we're going to be looking at this first term here and this first term here, and we're looking for a value that is going to multiply to 2x squared. That makes 6x cubed, and that is going to be a 3x. So if you remember from last unit, we need to now multiply 3x to all of my divisor here, so that's going to give me 6x cubed minus 3x squared minus 3x. And now I need to change the sign of all of these. So these are going to subtract out. That is going to give me a negative 2x squared. And this is going to give me a positive 7x minus 1. And now I'm going to go through this process again. So now let me erase these little lines here. Now we want to look at this 2x squared, and we're going to have to multiply times 2x squared to make a negative 2x. So that's going to be negative 1. So let's multiply. We get negative 2x squared plus x plus 1. And now we want to change our signs. And the reason we change our signs is because we're going to subtract off this product here. So when I subtract this negative, it turns to a positive. We subtract this, it's going to turn to a negative, and this one's going to turn to a negative. So now these are going to subtract out. This leaves me with 6x minus 2. And what we're left with is the remainder. Now for the purpose of this exercise, we're looking for the slant asymptote. So the slant asymptote is actually going to be equivalent to our quotient here. So the slant asymptote is going to be y equals 3x minus 1. And that is our final answer. All right, let's move on to our second example. So if you would at this step, why don't you pause the video, and I would like for you to try this particular problem. All right, so we've got our, let's confirm that we have a slant asymptote. We look at the degree of our numerator. So the degree of the numerator is 3. The degree of our denominator, I cannot spell today, is 2. Since we have a difference of 1 here, we know we have a slant, so we're good on that end. All right, so let's do some long division. So we have x squared, and I'm going to put a placeholder in here. So I have plus 0x minus 2, because I can see that we have some terms that are missing. And I have 7x cubed plus 2x squared minus x plus 3. All right, we're looking at these two. All right, so what do we multiply by x squared? And that's going to give us a 7x. So we have 7x cubed plus 0x squared minus 14x. And now we need to go through and subtract this. So that's going to change this to minus and change this one to a plus. So these subtract out. This is going to leave me with 2x squared. And this is going to give me a plus 13x, and I bring down my 3. All right. So now we've got our x squared, and we need to figure out what do we multiply by x squared to make 2x squared, and that's going to be a positive 2. So if we multiply, we get 2x squared plus 0x minus 4. And now we'll subtract all of these. So we end up with 0, 13x plus 7. This is our remainder, and this is our quotient. So our slant asymptote is going to be the line y equals 7x plus 2.